All right, so let's take a look at question 7. This is important, and this is part of why we had to learn the difference between distance and displacement. But when we look at the speed of an object, it's actually not the same thing as the velocity of an object unless they're going in a perfectly straight line. But we can see here, this says that the car is going around a circular track. We also do have a small problem that we've got miles per hour for our units here and minutes as part of the question. So we'll have to, at some point, probably fix that. Okay, but let's think about what we know. If we use our formula from earlier, where we were talking about velocity and distance and time, and how I said we can sort of interchange those things a little bit, we can take that formula and for our purposes, we can get a new definition out of it. We can say that speed is equal to, in this case, distance divided by time. And that's an important distinction, as we'll see in question 8. But so far, this is our definition that we'll use. There are a few different ways that you can handle these units. Again, these don't match. But we can actually convert those in our work. So as we go along, we can go ahead and make things line up properly. So here we can say speed is the distance. So here, around in a circular track, we are considering the full path around. So that's 1.71 miles. Then the time here is 0.48 minutes. And I hope you noticed if we leave this the way it is right now, that we would have miles per minute, which is not what we want. We want miles per hour. So we can build in this conversion. And so all at one time, we build in a conversion fraction, which, sometimes students aren't fully comfortable with at first, but are really handy. Because in this conversion fraction, we can design what's going to replace or be replaced and what shows up. So in this case, the minutes don't really fit with what we're trying to do. So if we put them at the top of this fraction, they're going to cancel with each other. And then the fact that we want miles per hour means that the hours have to show up somewhere, and conveniently they are in the bottom of this fraction, and so that's going to leave us over with miles per hour. Notice that I did the units first and not the numbers. Common mistake is students go, oh yeah, 60 has something to do with this, and then randomly take a stab at multiplying or dividing and hoping one's an answer choice. So it's important to make sure you understand why you've done something, so hopefully you don't take any unnecessary or incorrect steps. All right, but now that we've fully planned and decided what we need to do, fill in the numbers. We have 60 minutes is 1 hour. We can check through just like we wanted. Minutes and minutes cancel, miles and hours are left over, so this is all like we want it to be. To evaluate, on the top we have 102.6 and then 0.48 on the bottom. So it comes from multiplying the tops, technically multiplying the bottoms, but that one doesn't really do a whole lot. The units that are left over from a previous work are still miles per hour. So then now to finish up, we just want to take and divide these, and we get about 213.75 miles per hour.